Hi and Assalamualaikum to Madam Nur Faizah Binti Haminudin as our lecturer for BMMH3553 for heat transfer subject. So today I want to present topic about the conduction graphical analysis on heat transfer. So my name is Muhamad Haziq. So let's go to our introduction.
Hi, my name is Masdika Ubong. The topic of my presentation is about introductions of fins. In the first part, fin surfaces are in many engineering situations made out of fins to improve heat dissipation from a surface to its surrounding. Common applications of fin surface are wave condenser, air conditioning system, and transformer. Then the available surface is found indicates transfer the required quantities of the heat with available temperature drops and convective heat transfer coefficients. Extended surface of fin are used. At the same time, in engineering applications, largest quantities of heat must be dissipated from small area. The fin increase the effective area of surface, thereby increasing the heat transfer by convections. For the next topic, which is selections of design, I pass to Amirul Wafiy. Thank you. That's all from me.
Okay, today I'm gonna explain about the selection of design. For the design one, we use the square concept. As you can see, this is the diametric view. The second one is from the side view. The fin surface is 40 mm and the height of the fin is 15 mm. As you can see, the fin is lean about 89 degree and the length of the top of the fin is 39.48 and the thickness of the fin surface is 2 mm. Okay, for the front view, the fin surface is 40 mm and the thickness of the fin is 1 mm and distance between the fin to another fin is also 1 mm and the thickness of the fin from the top is 0.48. Okay, for the top view, the area is 40 mm times 40 mm. Okay, for the design number 2, we use the wave concept. As you can see, this is the diametric view. The second one is from the side view. The fin surface is 40 mm and the height of fin surface is also 40 mm and the fin is about lean about 91 degree, as you can see in this picture, and the fin surface thickness is 2 mm. Okay, from the front view, the thickness of the fin is 2 mm and the distance between fin to another fin is also 2 mm. Okay, for the top view, the angle of every wave is 29.65 degree and the thickness of the fin from the top view is 0.59. Okay, that's all from selection of design.
Okay, so we go to the analysis of the selection fin design. So yeah, we have two design, which is design 1 and design 2. So basically we can see that have some difference between the height of the design. So without waste time, so we go to the difference of the two design. Yeah, so about the characteristic, for the design 1, we can see the shape of the fin. We use the square shape as well, and yeah, for design 2 we have a design the wave concept for the fin. Yeah, but we have a different distance between the fin, which is for the design 1, which is we use 1 millimeter, and yeah, for design 2 we just add another 1 millimeter, become 2 millimeter. And yeah, for the height of the fin, we design 50 millimeter for the design 1, and we design 40 millimeter for the design 2. So you can see the higher for the design 2 than design 1. Yeah, so the material of the fin, we use the copper because they have some thermal conductivity, have same thermal conductivity. And yeah, we have a different total of the fin, 19 for the design 1 and 10 for the design 2. And yeah, we follow the heat flux, which is 1500 for the both design. And also for the heat power supply, we supply the 65 watt for the both, because this heatsink we want to apply for the electronic device, so the majority and the range we need to the 65 watt as well. And we can see the range of the temperature, that's 78.0 to the 98.0 for the design one, and have some difference which is 76.0 to the 98.0 for the design too. But we follow the guidance simulation as well. For the average temperature we use 76.6 for the cool side, but the hot side we use 97.3 for the degree Celsius for the hot sides. And we use the same convection coefficient, which is 5.03 watt over meter cube Kelvin. And for the analysis of the graph range of the temperature, we can see that for the design one we have some horizontally at the moment, and it go down slowly, but for the design 2 we can conclude that the temperature drastically goes down and become cool. So there's some analysis for the between the two design of it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shuhada Binti Kasri. Today I want to explain about the discussion of this project. As we know, the process of heat conduction depends on 4 basic factors, which is the temperature gradient, the cross-section area of the materials, including the fin length, and the properties of those materials. First, a temperature gradient is a physical quantity that describes in each direction and at what rate the temperature change. As everybody knows, temperature always flows from the hot area to the cold area. This transfer between bodies continues until the temperature difference decays and the thermal equilibrium occurs. Cross-section is also one of the important factors in this process. The greater the area of the materials in the transfer, the more heat is needed to warm it. Along with the more surface area that is exposed to the open air, the higher possibility for the heat loss. In this case, design which is taller has the best way of maximizing the loss of heat energy. Next, when it comes to conducting heat, not all substances are created with equal properties. In this project, we use copper as the materials, where it is one of the excellent heat conductors. So, this material is very suitable for conducting the heat. Finally, fin efficiency is one of the parameters that makes a higher conductivity materials important. A fin of a heat sink may be a plate with heat flowing in one end and being dissipated into the surrounding as it travels to one another. As heat flows through the fin, the heat will decrease from the base at the end of the fin. So, a lower temperature at the end of the fin is the best design to choose. Thank you.
Okay, for the conclusion, we choose design 2, which is wave concept. It because the height is higher than design 1, which is 40 mm compared to 15 mm. It is because heat transfer through fin of design 2 configuration is higher than that of other fin configuration. Temperature at the end of fin at design 2 configuration is minimum as compared to fin with other type of configuration. Choosing the optimal height of fin of design 2 configuration will reduce the cost for heat transfer process and increase the rate of heat transfer. Okay, that's all from conclusion, and that's all from us. Thank you for watching. Thank you.